Section 7.2 is on solving nonlinear systems algebraically. Yay! We don't have to do it graphically today. No graphing, we get to use algebra, and if you're like me, you love algebra more than you love graphing. Alright, so let's go through the steps. We actually did this last year. As you'll see, we'll do a linear example here, and that's just like last year, and then we'll move on to the linear quadratic and the quadratic. So fairly quickly, here's the steps. I'll let you stop the video and write them down. Here they come. Step 1 is to isolate one of the variables. Usually it's going to be y in one of the equations. The way the book teaches you to do it is to isolate y in both the equations and then make the two equal to each other. That's fine, you can do that if you want. I choose not to do that. I just isolate y in one of the equations. But it's fine, if you want to do it the other way you can. You can look at the book for that. Step 2, substitute into the other equation. Step 3, solve the resulting equation. And step 4, substitute your solution into one of the original equations to solve for the other variable. If you want a step 5, there is one in the book. I guess I should have put it here. Step 5 would be check the solution or solutions, but we know that most of you don't do that because it takes so long, but you can do that, and it's not a bad thing to do if you have the time and you're on a test or quiz or something like that. Okay, linear. This will not be, there won't be any of these questions this year. This is review from last year, but I thought I'd do it just to remind you of the process. First of all, I apologize for two things. I apologize, one, for putting y before x. It doesn't really make a difference, but it's kind of weird to put 2y plus x equals 9. Usually put x plus 2y equals 9. Sorry about that, and I'm sorry also for this editing job. Your sheet that you have in front of you should not be so ugly. I should have corrected it. I realized when I was shooting this video that I had the x and y the wrong way. Anyway, blah 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 blah. Let's try to solve this. So basically there's two ways we could solve this. One way is by elimination. That's when you get either the same number of y's or the same number of x's. In this case it would probably usually x's by multiplying all these terms in the first equation by 4, and then either add or subtract. If you don't remember that, don't worry about it, because you're not going to use that this year. I mean, you can if you want, actually, but I would say 95% of the time, the easier way to solve this is by substitution. So that's what we're going to do this year, substitution. And the steps I gave you up here are totally based on substitution. So step 1 is to isolate one of the variables. So you got to figure out which one of these variables, this y or this x or this y or this x, which one would be the easiest one to isolate. And this is going to stink because when I erase it, now you can see what my mistake was. Oh, I'm so embarrassed. So this is a y and this is an x. Anyway, my question is, which one of these variables is easiest to isolate? And I hope you agree with me that that's the easiest one to isolate. Okay, so let's do that. Let's get that x by itself. So what we end up with is x equals 9. And if I'm going to move the 2y to the other side, it's going to become minus 2y. You could also have this as x equals negative 2y plus 9. That's fine. Now, what we now have is a different name for x. A different name for x is 9 minus 2y. So where I see x in the second equation, right here, I can put 9 minus 2y. It's another name for x. So that's exactly what I'm going to do. I'm going to write the second equation, 3y minus 4x, but I'm not going to write x. I'm going to write 9 minus 2y equals 8, and then I'm going to solve that. So hopefully you remember how to solve algebraic equations. If you don't worry, there's a video for that. There's a video for everything. Find it and watch it. Assuming you do remember, let's do some mountains here. So you end up with 3y, negative 4 times 9 is negative 36, negative 4 times negative 2y is positive 8y equals 8. Let's combine the 3y and the 8y. You get 11y minus 36 equals 8. Add 36 to both sides, so we get 11y equals 44. Divide both sides by 11, we get y equals 4. Great, so we isolated the variable, that was this step. We substituted in, that was this step. We solved, that's what we just did. And now we substitute this solution, the 4, into one of the original equations to solve for the other variable. In other words, I have to take this 4 and I have to plug it into one of these two equations here. Which one's easier? I don't know. Let's plug it into the first one just because I didn't have to correct that one at all. So I'm going to plug it in there. So I get 2 times y, which is 4. So 2 times 4 plus x equals 9, and I solve that. 8 plus x equals 9, x equals 1. Okay, so y equals 4 and x equals 1. I've solved it. If you want to check the solution, see if it works. 2 times 4 is 8 plus 1 is 9. Good. 3 times 4 is 12. Take away 4 times 1 is 4, and 12 take away 4 is 8. Yeah, that worked. I'm confident that I have it right. All right, the rest, the new stuff today is pretty well exactly the same. It's just you're going to have some quadratic stuff. So we're going to solve for y and then plug in. All right, if you look at the first question here, it's already solved. Like you can see, you already have y isolated, so you're good to go. You can plug this whole thing into y in the second question. So you end up with 2x minus, in brackets, you got to put it in brackets, x squared minus 3x minus 4 equals 4. So be careful here. This minus sign here refers to everything inside that bracket, so all the signs are going to change. So it's 2x minus x squared plus 3x, right? Because it's take away negative 3x, so it's plus 3x. And take away negative 4 is plus 4 equals 4. Now, how do we solve? Well, let's combine terms first, the 2x and the 3x. So we get negative x squared plus 5x plus 4 equals 4. This is a quadratic equation. How do we solve quadratic equations? Make them equal to 0 and factor. If you can factor, you might not be able to. All right, so should I just move this 4 over? Yeah, what we actually like is to have that x squared term be positive. So let's move these three terms over to the right. This should all be review for you, so I'm going pretty fast. Move the negative x squared over, it's x squared. Move the 5x over, it's negative 5x. Move the 4 over, that makes a negative 4 here and a negative 4 here. So that's it. You just end up with x squared minus 5x. What do I do now? I have to factor. You can factor that. Yes, you can. You can take out a greatest common factor. You should always try to do that first. And what you're left with is x minus 5. How many factors do I have there? 2. One's x minus 5 and the other one is x. So there should be two solutions here. Yes, one solution is 0. If this x here was 0, that would work. The other solution is 5. Great. Am I finished? No. You must now figure out the y values for each of these two solutions. So you got to plug 0 into one of these, get an answer, and then plug 5 into one of those and get an answer. All right, I think it's easiest to plug it into, well, actually the first one's probably easier for 0, but let's plug it into the second one. So if I plug it into the second one, I get 2 times 0 minus y equals 4, and I have to solve that. 2 times 0 is 0, so I get negative y equals 4, which means y is equal to negative 4. Okay, so one answer is x equals 0, y equals negative 4. Or you could put 0, negative 4 like that if you want. That's fine. All right, now we've got to figure out what happens when I put 5 into that same equation. So I have 2 times 5 this time. Take away y equals 4. So 10 take away y equals 4. Subtract 10 from both sides. Be careful here. This is a lot of my grade 8s having troubles with solving this type of question. This is a positive 10, so subtract 10 from both sides. You get negative y equals negative 6, so y equals 6. Okay, so when x is 5, the answer is 6. You could check those answers. You could put 0 into this x, and you should get negative 4 on the side. Put 0 in here, negative blah, blah, blah. And you can also put 5 and 6 in those, and you should get the right answer as well. I'll check my answer, because I actually did this one before, and yes, I got the right answer. Good. Let's go to the next page. Another linear quadratic. So again, we have the y. This question is virtually the same as the last question, except there's a 3 instead of a 4 here. So again, we have the y isolated. Let's plug that into the y spot here. So we get 2x minus x squared minus 3x minus 4, but this time it's only equal to 3. And minus x squared minus minus makes a plus 3x, minus minus makes a plus 4 equals 3. Combine the 2x and 3x, I get 5x minus x squared plus 4 equals 3. Let's move everything to the right hand side. So I get 0 equals x squared minus 5x, and I'm going to take away 4 and take away 4, so I get minus 1. X squared minus 5x minus 1. And now what I would like to do is I would like to factor. So I'm looking for two numbers that multiply to 1 and subtract to 5. Not happening. There's no such numbers. So you can either complete the square, which I think none of you will do, or you can use x equals negative b. Right? So that's what we're going to hear. X equals negative b, so that would be negative negative 5, or 5, plus or minus square root b squared, so that's negative 5 squared minus 4ac, 4 times 1 times negative 1 for c, divided by 2a, so 2 times 1. X equals 5 plus or minus the square root of 25, that's negative 5 squared, minus 4 times 1 is 4 times negative 1 is negative 4 all over 2. So x equals 5 plus or minus the square root of, that's a plus now, isn't it? So it's 29 over 2. And it'd be nice if we could just stop right there. But we can't, because those are our x values. We need to figure out our y values. Alright, so one of our x values is 5 plus root 29 over 2. And we've got to get a y value over here. And the other one is 5 minus root 29 over 2, and we got to get a y value over here. How do we get that y value? Well, why don't we plug these into right here, I would say is the easiest place. That x right there. Sorry about this, dude. Okay. So we're going to plug it in there. So if we take a look at the top one here, right here, we would have 2, this 2 right here, times x, which is 5 plus root 29 over 2, minus y. Oh, my brother-in-law shared something on Facebook, which is very strange. That keeps showing up, even though I've ended my Facebook account, I've completely shut everything down, and I keep getting these updates in the corner of my computer. It's very strange. Anyway, enough of that. Equals 3. It's true, people. I have ended my Facebook account, and I have to tell you, I have so much extra time. I really encourage you to all do it. And from what I've heard on the report, TV reports, teenagers are starting to end their Facebook accounts so that their parents can't keep track of them. Once again, I'm ahead of you teenagers, hipper than you teenagers. Okay, let's solve this. So what happens here is when I multiply 2 by all this, it's so beautiful because look what happens. That just cancels out. So I end up with 5 plus root 29 minus y equals 3. Well, I think the easiest way to solve this would just be to move the y over to the right. That'll make it positive y, and the 3 over to the left. So that would mean the y comes over and becomes positive y. The 3 comes over and becomes negative 3, so I'm going to minus 3 and minus 3. So I end up with 2 plus root 29. So that would be my x value there. 2 plus root 29. Now, when I do this again, but I have a minus sign in here, everything's going to be the same. You're going to cross those out. This is going to be a minus sign. 3 is going to come over. It's just going to be 2 minus root 29. So that's the only difference there. Okay, those are your two answers right there. This is one solution here, and this is a second solution there, and they both work, and you'd be expected to write all of that. Okay, pretty crazy, ugly looking answers, but those are the solutions right there. Okay, I'm going to get rid of this. How many more do I have to do? 2 more. Oh gosh. All right. I'm the one who made the video, made the worksheet. I don't know what I'm complaining about. But anyway, let's get one of these y's by itself. I don't know. How about this y in the first thing? It'd be pretty easy to get that y by itself. Just move the negative y over and end up with x squared equals y. Great. This is another name for y. Another name for y is x squared. So where I see y, I'll put x squared. So I'm writing the second equation, but instead of putting y, I'm putting x squared equals 4. Combine those x squareds, I get 2x squared minus 2x equals 4. It's a quadratic equation. How do I solve those? Make it equal to 0 and keep that x squared positive, so just move the 4 over. 2x squared minus 2x minus 4 equals 0. What do I want to do now? Greatest common factor. Yes, 2. So x squared minus x minus 2 equals 0. Don't need to worry about that 2, because you know that that's not equal to 0. So if you want, you can just ignore it. But we're going to factor this trinomial here. Two numbers that multiply to 2 and subtract to 1. Hey, there are such numbers. 2 and 1. So we get 2 and 1 and minus, because I dropped that down, and a negative times a positive, and it still equals 0. So what would our solutions be? X could be 2 or x could be negative 1. Sadly, we're not finished. We need to plug those back into one of these equations. Let's do the top one. So if x is 2, I would have 2 squared minus y equals 0. So 4 minus y equals 0. Why don't you move the y over? You get 4 equals y. Okay, so one solution is 2, 4. If you put negative 1 in there, you'd get negative 1 squared minus y equals 0. Negative 1 squared is 1 minus y equals 0. Move the y over, you get 1 equals y. So the other solution is negative 1, 1. Those solutions look much nicer than the last one. And so our answer is 2, 4 and negative 1, 1. And you could check those if you want. I'm checking my sheet, and yes, we got those right. Okay, last one. Look at this. This is what the book always does. They always make it so you've got y isolated in one equation and y isolated in the other equation. And since y is equal to this and y is also equal to this, then these two underlined parts must be equal to each other. That's the way they think of it. I just think of it as once you have one of them isolated, you can just plug it into the other y. Anyway, however you do it, you're going to end up with x squared minus x minus 3 equals 2x squared minus x plus 7. We want to get everything equal to over to one side to make it equal to 0. Which x squared, or do you want to move everything to the right or to the left? To the right, so the x squared stay positive. So we're going to end up with 0 over here. Take away x squared from both sides, so that will leave you with, do you want me to show you that? Take away x squared, take away x squared. We're going to add x and add x. And we're going to add 3 and add 3. That's probably hard to see. 2x squared minus x squared is x squared. Negative x plus x is nothing. And what is it? 7 plus 3? Yeah, so x squared plus 10. Okay. Oh, now we want to factor. You can't factor x squared plus 10, so you could use the quadratic formula or whatever. But look at this is one of those ones where you don't have a b value. Remember these ones? These are the ones you can solve by using square roots. You could isolate the x squared. So let's do that. Let's move the 10 over. So we have negative 10 equals x squared. And then undo the squared. In other words, take the square root of both sides. And of course, make it plus minus. And are you freaking out a little bit? I hope so. Square root of negative number, you can't do it. So what does that mean? No solution. You can just write that, or you can write no solution. So what's that mean about these two parabolas? That means they look something like this. I don't know exactly, but it means they don't cross each other, right? Remember, that's what you could still graph all this and get the same answers, just like we did last time. It's the same thing. If you graph these two parabolas right here, they would cross each other at the points 2, 4, and negative 1, 1. Don't lose sight of the fact that you could have done this by graphing.